Nu o să avem foarte mulți participanți în seara asta, dar mă bucur foarte mult să văd că ați venit și la această ediție de Talks. Avem doi speakeri minunați în seara asta. Trebuie să îi mulțumim lui Radu, care este unul dintre voluntarii șefi aici și care s-a ocupat de speakeri și la această ediție, alături de întreaga echipă de voluntari. Voiam să vă mai spun că suntem așa pe piața asta a meetup-urilor pentru comunitățile tech de, nu știu, vreo 5 ani să fie. Unde Alexandra? Alexandra, câți ani sunt? 5, nu? 5 ani. Zic bine? Zic bine. Și între timp mi s-au alăturat foarte, foarte mulți oameni, dar în mare parte vi se datorează vouă că a ajuns comunitatea asta să crească atât de mare și frumoasă și aș vrea să vă aplaudați, dacă vreți, ca să fie așa, cu mult spor și multă încredere pentru mai departe. Ca să nu mai prelungim foarte, foarte mult vorba, aș vrea să-l invit pe primul speaker, care este de altfel deja aici lângă mine, Alin Pandichi, The Sorry State of Frontend Code. Ce ne zice seara asta?
Despre ce este prezentarea?
Da, așa, pe scurt,
este un rezumat al pattern-urilor greșite pe care le aplică developerii de backend atunci când își bagă munițile prin codurile frontend.
Așa, să-ți adreseze întrebări în timpul prezentării sau să așteptă până la final?
La final.
La final.
Aș prefera, mulțumesc.
Super.
Bine, te rog.
Ok, mulțumesc. Quick question, should I talk in English or English? Yeah? Okay, perfect. So let me just start a timer here. So, thank you for the introduction. Once again, my name is Alin and I'm a software developer at Mosaic Labs. And today I will talk about the sorry state of front-end code, like I said, as written by the back-end developers. And the disclaimer that I want to start with is that front-end code written by front-end developers is fine most of the time. However, front-end code written by back-end developers is not fine most of the time. I don't want to bash back-end developers, but I just want to nudge them in the right direction. I say this because I'm a back-end developer. I identify as a back-end developer mainly. But I've written front-end code and I've seen bad things that I've written in front-end code, and I recognized them, and I made a list of anti-patterns that come up in front-end code written by a back-end developer. So I want to share that with you. Just a quick question, how many of you identify as back-end developers mainly? Okay, so quite a few. So this talk is for you, mainly. This is a tweet that identifies a problem in the tech industry, in the software development industry. And it says that there's basically no company that hires people doing just HTML and CSS. And we can even try this right here with you. Raise your hand if you work in a company where you have people that write only HTML and CSS. Oh, okay. So there's a few. The last time that I did this talk, there was no hand up in the air. So that's new. That's fine. Perfect. Awesome. What happens instead, we have, if there's no one writing just HTML and CSS, we have backend developers, we have people that write code in the backend, meddling in the front end. And when that happens, they don't actually enforce rules that they usually do in the backend. And they just want to do the work quick and dirty, and they have an idea that the front end is not that important as the back end, because they believe that back end is the engine, that's where all the work happens, That's everything that matters, and front-end is just something that we have someone that's cheering here. Front-end is something that just gets in the way, and we have to deal with it quickly and move on. Well, it's not that simple, and it's not that's not a very healthy attitude. So another thing that happens is developers believe that they will, if they do a mistake in the front end, they will go back to that code later on when they have more time, and they will fix it then. But guess what? They never do. I certainly didn't when I should have. So the code, the front-end code written by back-end developers tends to pile up into a big dump, big scrapyard, and that's not ideal. In time, it will be harder and harder to make changes to that code, and it will prevent delivering features in time. So in order to prevent that, in order to not make these mistakes, or if you did make those mistakes, if you ended up with code, with front-end code that kind of looks like a scrapyard, what you can do to fix the problem is to apply the Boy Scout rule, which says that you should leave the place cleaner than you found it. So what that means is that in time, at least once a day, or when you go and write some code in the front end, if you want to add something, you should take a minute, you should take some time to fix something, to make it better, to make it look better. In time, if you do that, day after day, after a month, after a year, the code will look much better than it did previously. It will bring the front-end code to a better state. And you might ask, okay, what can I do in a few minutes? What can I do in a short span of time? It turns out you can do a lot, actually. You can fix some inconsistent naming. You can fix abbreviations in variable names, for example. You can clear up the intent of the code, because sometimes whatever the code says it does, actually it doesn't. You can clean up the big pile of CSS, because there's something that I've seen. We have a single file of CSS and we dump everything there, instead of actually splitting the CSS files into something more modular. What we can do is to remove commented code, because that's useless. Commented code helps nobody, and it actually prevents or distracts from the real problems. Some developers believe that they should leave commented code in place because who knows whenever they might need it again. Well, guess what? I certainly believe that you will never use that code again, ever. So it's better off if you delete it. You can update outdated comments, or you can delete actually the comments in code, because comments actually are not a good idea if they just state the obvious, or if they are not actually up to date with what the code does. So you end up with code comments that are actually hurting the people that are reading it, because they spread misinformation. Another thing that I've seen, and that is an anti-pattern in front-end code written by back-end developer, is the God file. You may know the concept of God class. That's the class that contains a lot of code, thousands of lines of code, that is omniscient, omnipresent, omnipotent. we have the same thing happening in Frontend. We have view code that is a God file. And this is an example of code that I've taken off GitHub. It has at least 4,000 lines of code. You can see a lot of divs. There's indentation that goes beyond the screen. That's how bad it got. And we even see we have comments that tell us here's where pagination ends, here's where a tab ends, here's where content ends, and so on. Because this file is so large, you actually lose sight, you lose track of where you are in the file and what you're actually editing. And not to mention the accolades, the parentheses here that kind of tell me there's an if or a while loop, something like that, upper in the code. And you can imagine what this code actually contains in these 4,000 lines of code. There's quite a lot, very much, too much actually, happening in this one file. And if this one file contains a lot of code, you can imagine whatever is left in the rest of the project. Instead of having this, why not splitting a view file like that? Why not split those files, thousands of lines of files, into something where you can clearly see what's happening? You can split it in pages that you can then scan in one look. You can see in this file, okay, I have a header, a navigation menu, a landing page description, the latest news, a contact form, and a footer. It's very easy to reason about this. There's no just 6 lines of code, not 4,000. And if I need to know something else about the contact form, I can go there and inspect that code only, and I know where I am. I'm not getting lost. I don't risk getting lost in this kind of code. So better organizing your code can actually do a lot for you. Another problem that we see often is duplication. And let's take an example. We have some divs and labels and inputs. Obviously, if we take a few seconds and scan this code, we can see that it's some kind of form that takes first name, last name, and email. Well, all that structure of a div, label, and input, it repeats. It might not be that obvious, but that structure can be extracted. It's something that we can isolate in a template, and instead of duplicating and copy-pasting that code whenever we add a new field into that form, we can have just another line, another template form, input field, something else. And again, it's very easy to reason about this code now, instead of maybe in time having this file reach hundreds of lines of code because we have 10 or 15 fields in the form. Another example that I can give is one from the project that I'm working on. We have here, for example, a few lists of speakers, and we have a list of confirmed speakers in case of a conference. So I'm in the context of being conference organizers, and I'm looking at a summary of the speakers that I'm accepting into my conference. So I have a few confirmed speakers, accepted, under review, rejected, and cancelled. The important part in this screen is the fact that the grid of speakers is something that repeats. It's something that I can extract the structure of this view, because we have a grid of photos, speaker photos, and we have something to the right side, a link that I can click to show more, because we have a limited view, we have a responsive view, and we have something that we need to have something that allows us to load the rest of the speakers. So this is something that repeats, because I have this structure, this grid, with this responsive grid is something that repeats. I have it in this particular file, in this screen, and I have it in several other places. So it's something that I can extract. I don't have the code to show you, but you can imagine that it's something generic enough that you can extract into something that can be reusable. It's a grid of stuff, a grid of photos in this case, that can be expanded if I click a link, and that can be hidden if the view is not wide enough. So there's a certain list of requirements that this component, let's say it's a component, this list of speakers. There are certain requirements that I can extract and that I can reason about, and I can put them into a template, and then whenever I need something similar, whether it's a list of speakers or a list of something else, it doesn't matter, because the template that I extract from here is something generic enough and reusable enough. If I don't do this, I end up duplicating a lot of code. I end up copy-pasting a lot of code. So that's not something that I want, because in time that will become something very difficult to manage and to maintain. Another example is, for example, a dialogue form. I have a dialogue, and in this dialogue I click link, whatever, a button, and I show up a dialogue with a form. And it has a few fields and 2 buttons, save and cancel. Somewhere else, I have pretty much the same thing. It's another form, but the dialogue is the same. The concept of a dialogue, the behavior of a dialogue is the same. And again, another dialogue. I have countless of other dialogues in my applications, and they all behave the same. I click a button, I bring up a model window, I have something inside, it's a content, a few fields, and I have 2 buttons, cancel and save. And the save action is something that depends from one form to another. These concepts, again, are something that I can extract. It's a list of requirements, it's a list of things that can be abstracted away into a template, into something that can be reusable. It's a dialogue with some actions, cancel and save. I can provide that action at runtime depending on what I click. And the same can be done with the content of the dialogue. Depending on what dialogue I need, I inject that content into the dialogue. So the code that I have for this dialogue is just one file, but I reuse that, and it doesn't matter what dialogue I need. I just define a new list of fields, a new save action, and then I can... No sound? Anyway, it doesn't matter. I can reuse that dialogue, I can reuse that code. Another problem is unit testing in front-end code, in JavaScript code. And to be more exact, the problem is the lack of unit tests. How many of you in this room are writing JavaScript without unit tests? So quite a few people. And I'm not sure how large that code base of yours is, but if it's larger than a few thousand lines of code, then it's a problem, because that code is not covered and you have to manually test that code every time you change it. And I wouldn't want to be that person that does that. Things that prevent us from doing unit testing in front-end code, in JavaScript, for example, is high coupling. We kind of couple everything together. We treat everything as a big pile of stuff, a big pile of data, a big pile of code, and we don't properly isolate and split the code into modules. Or we do not respect the single responsibility principle. For example, let's say we have some code, and this image is something that describes a generic piece of code. You can easily imagine that the red code is something that deals with the backend, with data fetching, and the blue is something that validates, and the lightest blue is something that so I'm sure that somewhere in your code bases there's something similar, where a piece of code, JavaScript code, a function, does way too much in terms of responsibilities, and you can split that. One of the things that prevents you from writing the unit tests is not having properly separated those responsibilities. For example, we have third-party dependencies, like, I don't know, jQuery. There's a library that everyone used at some point. For example, this code fetches some data from the backend, and then, depending on that data, it increases the width of some sections in the website. And we can replace this code with something equivalent and testable. This code in this state is not very testable, because you have to mock somehow the jQuery library. But there's another way. You can refactor this code, and you can remove that dependency or push it out of your code, out of your business code. This code, for example, is the equivalent. I have extracted, you can see in the lower side of the screen, there's dealing with the document loading, with the Ajax data fetching, and in the upper side I have extracted the actual dependency of the API of the jQuery, where I use the jQuery function for a specific ID and invoking the width, or setting the CSS property. And my business code function, my business logic, is the function in the middle. That function I can test, because I receive some data as a parameter, and I receive another parameter that I can mock easily. And then that code is much easier to test. Of course, you can say, but then you don't have full code coverage, because the first part of the code is not tested, the last part of the code is not tested. Okay, but at least I have my most important code tested. My business function is tested. Something else that I've seen, or that can the problematic is global namespace pollution, where you have, for example, as a developer that doesn't give much attention to the code, they just pile everything into one file or into some files without proper modularization. Well, you can do things better by using, for example, immediately invoked function expressions, like this one, where you have a counter and you isolate the data, the I that can be increased, and you also expose some methods, and then you can use that to do your business logic. Without proper encapsulation, you expose too much, and in time that can become problematic. Or you can, even better, you can use ES6 modules that allow you to even easier encapsulate functions and data and expose whatever is actually usable in or is actually important for the application. This is, for example, a module that exposes a constant and the two functions, square and computing the diagonal of a... Yep, that's my time. No, I don't have much left, so let's move on. You can have side effects in your code if you're not if you don't pay much attention. And for example, React is one library in front-end development that is trying to, or is very much popular because of that idea that you don't have side effects. If you use pure functions and functional programming and immutable data, you end up with reasonable code, code that you can reason about without side effects. All of this is a lot of info to take in. I encourage you to study this list of anti-patterns on your own and think about where you can actually apply these pieces of advice into your front-end code, because I can guarantee you there is something that you can improve in your front-end code. Thank you. My name is Alin. If you have any questions, please shoot. Yes?
Would front-end libraries solve much of the problems you described?
Like I said, they can. For example, I mentioned React. And React is a library that, React and Redux, for example. The combination of React and Redux can help you deal with better reasoning about where your data comes from and how that data is changed and displayed throughout your application. Because in using other libraries, it can be difficult to know where that data came from. You can have some side effects that you're not really quite sure how that ended up in your code, in your data. So some libraries, sure, they can help you, but that's not enough. That there's a mindset that you have to apply to your code. Some certain discipline to actually improve your code and to pay much more attention to it. Any other question?
Other questions? No, nothing?
No? Okay.
Instead of trying to be, how do you say, jack of all trades,
Right.
wouldn't it be easier? Okay, if we have like a specific thing to do, and our front-end colleagues are up to the neck in other tasks, we can try and implement a fix, maybe modify a test for that fix also, so we can have some coverage. But if there are bigger changes, wouldn't it be easier to just pass it to someone who really does this thing every day, instead of me as a me personally, I've been through phases. I mean, I had like almost a whole year in my career where I did front-end. Those were the time where jQuery shined. No, it was long before React and Angular and everything. But I had like almost a full year of front-end tasks, and then one day my boss came and asked, hey, did I hire you for front-end, right? No, you hired me to be a back-end developer.
Yeah.
Ah, interesting. So maybe, I don't know, at least at that point in my career and even today, I think if it's more than like something that needs to be fixed right now, and everyone else is booked with doing something, I can do it. But other than that, I'll leave them to do their React magic and whatever.
Yeah. Yeah. So, in an ideal world, yes. Instead of being a jack of all trades, you would deal with what you know best, let's say back-end development, and leave the front end to someone who knows better. Unfortunately, that doesn't happen. Like you said, companies hire people and then they just put them to work and they don't really pay attention if the person working on that stuff actually has the skills to properly deal with that. So it's, in an ideal world, yes, you should have people dealing with things where they are the most expert, but that doesn't really happen in the real world. So instead we have to pay more attention and to actually treat, that's the basic idea of this talk, treat your front-end code as you treat your back-end code, with more care and with more respect, basically.
So basically we should stop being arrogant about being
Yes.
back-end
Yes.
developers,
Yes.
which are smarter than front-end developers.
Right. That's
I totally
the idea.
agree with that.
Yeah, right. Any other question? Yes?
Ok, care crezi că e momentul în care ar trebui grupate efectiv controlele? Adică ai arătat două input box-uri sau, mă rog, era un input box și un label și ai spus că ok, ar trebui să fie o singură entitate. Sau butonul de ok și cancel, că ar trebui să fie ok, o singură entitate. Când anume în life cycle-ul dezvoltării decizi să faci chestia asta? Adică 90% în cazuri, scuze, mi se întâmplă mai degrabă să vină alți developeri să decidă ok, combo numărul 1 de buton de ok și cancel, combo numărul 2 de buton de ok și cancel și de fiecare dată când mai vine cineva și face o modificare, mai inventează un nou tip de buton de ok și cancel. Adică mi se pare mult mai frecvent scenariul ăla decât scenariul în care cineva n-a grupat butonul de ok și cancel, bine, buton de ok și cancel, înțelegi așa de fel, adică chestia asta encapsulată. Nu știu, când ar trebui să faci asta?
Ar trebui să o faci în momentul în care îți dai seama că lucrurile se duplică. Cum ai spus mai devreme, a venit cineva și a mai adăugat încă un gen de grupare de buton de ok și cancel.
Dar asta pentru că a crezut că e ok dacă le grupează din primul. Fără să
Păi
vadă
nu.
tot ce trebuie.
În mod normal ar trebui să vezi duplicarea asta de cel puțin de 3 ori. Adică adaugi întâi un dialog, spre exemplu cum aveam codul sau cum aveam imaginea acolo, un dialog cu un formular și un buton de ok și cancel. Ok, îl fac în prima așa cum este, nici nu mă gândesc la el. Mai departe, mai adaug un dialog. Ok, poate e din întâmplare, seamănă între ele, încă nu modific codul, încă îl duplic, îl las așa. Dar dacă vine o a treia instanță, un al treilea exemplu în care lucrurile chiar seamănă între ele, atunci mă opresc, adică implementez, am 3 chestii care seamănă între ele și atunci refactorizez, rescriu codul astfel încât să extrag partea comună și să păstrez doar ce se schimbă și apoi să le combin. Da, deci pe măsură ce dezvolți. În momentul în care observ că se duplică lucrurile de cel puțin 3 ori, atunci ar fi momentul în care ar trebui să spui problema, nu cumva aș putea să simplific lucrurile aici.
Da, practic, după 3 ori nu mai poți să mai negi, că n-ai văzut că există cod duplicat. Prima dată poate scapă, a doua oară poate totuși, a treia oară deja sunt niște semne de întrebare.
A doua oară vine șeful și spune, salut, mai ții minte unde era interfața așa? Schimbăm, nu mai e așa.
Ok, o schimbăm în
Adică
cazul ăsta dacă este a patra instanță
unde asta, că se schimbă de 100 de ori chestiile alea. Și ajung prea multe, prea ambigue și după aia dai complexitate inutilă la o chestie care, ok, ai mâniază ei programării că e copy-paste și te gândești, vai ce slab sunt, dar overall, adică dacă vine unul după tine, zice, ok, asta era prost, dar măcar înțelege ce trebuie să fac. Dacă i-am abstractizat toate alea într-un nest ăsta de componente infinite, o zic că da, sigur o zic că programatorul înaintea mea sigur a fost niște. Nu, o să te iei cum, adică asta face el.
Dacă se schimbă doar într-un singur loc, adică ai o a patra instanță care e puțin diferită, atunci poți să o iei de la capăt. Ok, duplici și ai o nouă instanță care e puțin diferită de primele 3.
Da, și practic mai adaug o proprietate generală pe toate ca să prindă toate scenariile și tot așa.
Depinde foarte mult de cod. Acum speculăm mult.
Noi vorbim de un cache cancel, dar înțelegi la ce mă refer.
Ideea este că ce se duplică și poate fi extras în ceva mai generic și mai reutilizabil, poți să faci. Dacă apar chestii care diferă puțin, atunci îți reevaluezi puțin opțiunile, duplici sau nu, sau modifici pe celelalte 3. Depinde foarte mult de la cazul acesta.
Și nicio strategie de code management nu te salveze de bad management as a business or as a project.
Evident, da.
Eu am observat, cred că e tot un fel de anti-pattern și sunt curios cum îl vedeți și voi și eu zice lack of ownership pe data structures fie de la front-end guys, fie de la back-end guys. Who's owning the data structure? Is the back-end, is the front-end, or both?
Both, because
Da, și data structures de la facultate.
right. Both should be the owners of the data structures, and in this case where there's communication with data between backend and frontend, well, I believe that backend and frontend developers should get together and decide and agree on the protocol of communication between that code, the backend code and frontend code.
But did you see this kind of problem in teams you work with?
Sure, but that's something that needs to be dealt with from case to case. Thank you. Yeah.
So my question relates to the fact that in the beginning of the talk you kind of implied that it's a good thing to have people in an organization who only code CSS and HTML.
Yes.
And I kind of have an observation. I've worked a lot with companies from Hungary. I actually studied in Budapest. And they came up with a pattern, it's like a business pattern, where they hire people who they call site builders. It's a Hungarian term. I mean, it's an English term only used in Hungary. They call them site builders. They are people who only know CSS and HTML, and they are very underpaid. Almost half of all front-end development job listings are for site builders. These are people who are, in my experience, usually afraid of JavaScript, and what they do is they code up in a very static, only CSS and HTML manner, all the views for an application. And if you're working as a front-end development company, for example with a Hungarian company who already has a few site builders, what you get is like 50 HTML files with all the views coded up in CSS and HTML, and I don't really get like how can you make use of people who only knew HTML and CSS, because from what I've seen, it's what happens is that the organization goes exactly against your patterns, like extracting duplicated code, dry principle, etc. And what I've seen is that so if we have site builders, you already know the term. If we have site builders on the team, what happens is total clusterfuck. So it's totally against good front-end development principles, and I'd like to know, like, how would you make use of these people?
We call them graphic designers and we pay them more money in Romania.
It's better here, yeah.
So my slide in the beginning was more about people who actually know their stuff. And I mean people who actually know their CSS and HTML and they have discipline about their code.
Yeah.
And I think that they're better to deal with some things just by thinking of some examples from my own experience where I had to fix something in CSS and for the life of me I couldn't, because I don't know all the inner workings of CSS, and it's something quite complicated from my point of view, and that would be better dealt with by somebody who knows this stuff.
Maybe
Actually,
front-end developers.
Right, front-end developers, right?
yeah, actually one of the like CSS stars on CodePen is a Romanian girl, I don't know the name, Anna. She's like incredible. Like 3D animations only with CSS, it's incredible.
Right. See, so
Yeah.
it's a very complex topic that can be put to better use. So I would not be fit to build stuff in CSS, but somebody who knows that pretty well can do a better job than me, and that's basically where I was trying to get at with that slide. Relating to your example, just one moment, the site builders, that's something that can be dealt with again by actually imposing some standards of quality. So if they're not actually better than me, then they're not really, they don't help me. So it's something that you need to evaluate how much better they are compared to, for example, what the developers, the backend developers in your team can do.
Yeah, I wanted to intervene here because I know good HTML and CSS coder that just do that. And if you have like, if you know how to structure your things, you can write dry, you can have templates, you can write BAM style, and you can have Gulp to build then your HTML, so you can demo it to people. So it doesn't need to be a clusterfuck. You just need to better organize yourself, write templates, even though you're writing just HTML and CSS, and then use other tools like Gulp to actually build your thing so other people can actually look over it. So if you know how to write your stuff, you can actually be a good front-end developer that just does HTML and CSS. And in today's world, HTML and CSS, it's humongous. It's huge.
But HTML and CSS and Gulp means HTML, CSS, and JavaScript.
Yeah, but you can focus on HTML and CSS. You should know a bit of tools these days. Like, you should know a lot of tools. Even if you're a strict front-end senior developer that writes only React, you should also know a bit of Node because you work with a bit of Webpack and other tools as well. So.
But that's a good front-end developer. It's not a person that knows just.
It's no longer a site builder.
Okay. Yeah.
Okay, I like to debate during the networking session. Thank you so much, Alin. I'm just taking a 5 minutes to prepare the setup for the next presentation, and then we'll get back with another 2 great speakers. So see you next.
Okay, so I have next to me Tibi, who is going to talk about unorthodox patterns using Mobix, that's right, Mobix and React. Okay, Tibi, I'll let you take the stage and, seduce us.
Hello, my name is Tibi Ionescu. I work as a front-end developer for Cure Technologies, which is a US-based company, and we are working on something like a chat application. And today I'm going to present to you some patterns that I came up with while working at this application using Mobix and React. Those are the main two technologies that I'm using in this application. Mobix is another state management library. So the first question that I want to address is, why do we need state management? While thinking of an answer for this question, my best answer to it was that we don't need it. I mean, if I start an application from scratch and my first question is, look, I need to get some state management involved, I don't think I'm starting from the right place, because maybe I'm developing a 3D game, WebGL or something, and I would rather be concerned of shaders and buffers rather than state management. Or maybe I write a to-do app, which is what most examples of state management look like. So rather than asking why do we need it, I thought of asking why do we use it, because most of us obviously use state management, and we use it because it offers us some advantages. First of all, we figured out that by using a third-party tool, a library like Mobix and React, and let it sync up our user interface with our data model, is more reliable and easy to use than just making jQuery calls and having a lot of trouble with that. So this is one of the first needs that was addressed by the new wave of state management libraries that came up across the years. Also, with React, Angular, and front-end libraries like this, we started splitting our front-end code into separate components and address the so-called separation of concerns. And while doing it, we still needed to access parts of our state in different components of our application. For example, in React, you have a built-in mechanism for accessing some parts of your data, of your state, down to the most low-level children of your application. You can pass it through the props of the components. But by doing it, usually what happens is that the middle components, most of them are not interested of what data you're passing down from the root of your application to the some low-level child of some level component. So state management libraries also address this issue. They offer some mechanism for sharing parts of your state with different components of your application. And also, while developing, while debugging, while addressing issues, it helps a lot of time to understand how state management, how the state of your application affects the user interface. So how things get updated, how, why do they get updated. So again, this is one other advantage of using a state management library. Before I start getting into Mobix, I just want to make the classical raise your hand and ask you how many of you use React as a front end. Okay. Does anyone use Mobix? Okay. And who uses Redux? Okay. So I know where to dodge the tomatoes and the stones that are going to come at me. Okay. I wanted to find the simplest way of describing the library. If you go to their website, their first line of description is something like it transparently applies functional reactive programming, something like this. I mean, some load of... I couldn't understand it the first time that I looked at it, and still I don't think it's representative for what it actually does. So rather than giving you the theory behind it, I just thought of the simplest example that with MobX. So what you're seeing is a working piece of code. If you have the modules installed and you run it, it's going to work. So there's no hidden configuration, you don't have action creators, you don't have reducers, you don't have anything like this. You just define some observable object, you use it in one of your components, and you change it by simply using some assignment operator, as you can see in the set timeout function. And because your React component is decorated with the observer decorator, and it tracks whatever dependencies you have within your render function. And each time that dependency changes, your component is going to be automatically updated. So obviously there are more ways of defining observable data structures. There are more ways of reacting to changes in your data structures. But at its core, the library is only about this. It doesn't have any constraints over how do you structure your code. And it does just this. And you don't have to couple it with React. React is a separate package for it, but it's the best library that you can combine it with, because the way React is built. And I also wanted to write some description of it, and I want to emphasize the simplicity and what it brings to the table for the developer. So you don't have constraint over your data structure, and its priority is to update your state and other dependencies based on your state updates. Feel free to interrupt me, because I realized I didn't make an in-depth presentation of MobX, and now that I see that no one uses it, it might be a little bit confusing. I focus mostly on the patterns, but I'm hoping that you are going to get a hold on how it works by looking at the patterns and seeing how easy it is to do some complex stuff with it.
I have two questions already.
Yes, please.
So one of the questions is actually when your observer changes, does it actually trigger any of the life cycles React has, actual component update or things like that, or it just changes the actual?
No. So if you look at this piece of code, the React component has that observer decorator, which is nothing more than a higher order component. I mean, that decorator is just syntactic sugar for it's equivalent to passing YMobX component as an argument to observer function. So this is what it does. And behind the scenes, it tracks for each render. For the last render, it tracks the observables that you use in your render function, and each time they change, in fact, each time they change, and also when the child is rendered because of a parent rendering, it uses should component update behind the scenes to see if there is a need for re-rendering the component. I mean, even if
it triggers the actual life cycles of React.
Yes, of course, it doesn't interfere with this. I mean, if the component was re-rendered, you will have component did update, and if the props are changing, you will have component will receive props, so on and so forth. And the main advantage of it is that even if you have a parent that is re-rendering, if you wouldn't use it, all of the children, and if you wouldn't use Redux or something like this, so you just use plain React and you render a parent, obviously all of the children are going to re-render. But in the case of MobX, if you decorate the children with observer, they won't change, they won't re-render unless the data that is used in the render function will change. So you have a level of granularity for controlling re-renders, a very high level of granularity for controlling this process.
I have a question as well.
Yes.
How do you keep track of the state changes in this pattern? Because in Redux you only change the states by hitting actions.
Yes.
You can see exactly when an action was measured and where you don't necessarily where it came from, but you can track this kind of stuff. And here it seems to me that if I have a component that changes the observable,
yes.
I don't know where it came from or what caused it.
Well, for understanding why things react to observable changes, MobX exposes some functions for you, but you are going to use that mostly for debugging purposes, because I mean, my real life experience with it is that I never use those kind of functions because it's quite obvious, and you can track them even on the stack trace, because everything in MobX is synchronous. So if you change, if I put a breakpoint inside of the render function and I go back on the stack trace, I will reach the set time of function that actually changed that observable. So you need to somehow get out of the Redux paradigms and just think in terms of, look, I updated something, MobX is going to take care of the rest and re-render only those components that depend on those observable structures. And also, this example is pretty simplistic, but MobX also offers some functionalities for batching multiple mutations. I mean, you can decorate your functions with an action decorator, and MobX will trigger a re-render only when the outermost action completes its execution. So even if you have 100 mutations for 100 properties on observables, depending on how do you structure your actions around those mutations, you can control how they are going to be batched. Does that answer your question? Okay. Here I had some. Okay. So why unorthodox? The thing with MobX is that it seems like it's going against what front-end programming, against the trends or hypes, or however you want to call them, of the front-end development world right now. Because everyone is going towards functional programming, immutable data structures, pure functions, so on and so forth. And MobX basically, you might use it in such a fashion, but that's not its purpose. I mean, it's highly mutative. You use plain object-oriented data structures and concepts. You simply have objects and mutated properties. Your functions are as impure as they can get because you mutate things directly into it. And also, and yes, you use mostly object-oriented concepts rather than functional programming ones. So I tried to use those kind of concepts myself in the project that I'm working on, but I quickly figured that it's really not the best solution because the nature of my project, being a chat application, is that you have chats, you have messages, there are entities that have a one-on-one relationship with the one on the back end, and they are constantly updated. I mean, I can have 10 events for the same entity at once, something like this. So updating it using immutable data structures for a chat entity which has 20, 30 properties that need to communicate with one another becomes cumbersome. So I had a lot of issues trying to use immutable JS, trying to use something like Redux. So this is why when describing MobX, even though I said it's unorthodox because it goes against the JavaScript trends of today, it helps you get the things done quickly and in a reliable fashion. And from my perspective, the code is very easy to understand if you look at it. Okay, so this is the summary of the patterns that I'm going to talk about. Let me start with the first one. So this is something that might make some of you cringe. Why would I need to replace React set state with observable data structures? And the answer again is that you don't. React set state is perfectly valid. You should use it however you want. But it has some quirks, and some of them might not be even obvious from the first time you start working with them. First of all, it's asynchronous. I mean, if I call set state and then I check the property that I updated in the next line of code, that property is still the value that it was before I called set state. This is not a problem in itself because you can pass a callback to set state, and you will that callback will get invoked when the state has finally been updated. But for example, I had some issues when I wanted to build a simple date input. So I had 3 text inputs, one for year, month, and date, and I had to deal with focus and blur events, which are synchronous, and I had a lot of issues because of the way DOM events are bubbled. So I needed to intercept when first input is blurred and when the second one is focused, to try to maintain some sort of a focus state for the entire input. So because set state is asynchronous, I simply could not get it to work right. Probably if I spent some more time, I might have been able to do it, but I had some problems with it. Also, when I'm talking about no control over when the render action actually happens, if you just you call set state, the render happens, but you need to find out when it has been re-rendered. Maybe you want to access some kind of DOM element after you call set state. For example, I'm working right now on a scrollable component, which is highly dependent of DOM events, and I need to access the elements constantly. So I also had some scenarios in which I called set state on multiple components, and I wanted to know when all of them have been re-rendered. So the way that I might have done it was, I don't know, it's hard for components to make components communicate between them, so that I know, look, the re-render has been finished for all 3 of them. Obviously you can do it, but you end up with some issues with it. Also, if you don't use any state management library, you just use plain React, if you call set state, the re-render will happen regardless of if you change something or not. I mean, if I just call set state with an empty object, a re-render will happen. If I update the property, which was 2, and I set it to be 2 again, the re-render will happen even if I didn't change anything to it. And when referring to component state and set state not being enough for it, I'm mostly referring to scenarios in which maybe you want to have a set timeout. You need to store that timer ID on something, and you won't store it on the component state because you won't use it in a render function, and you don't want the component to be rendered just because you initiated a timeout. So you end up having both a state. This dot state you access some properties, but you also have maybe this dot timer ID or something. You have state-like properties both on the React component instance. The solution to it using MobX, as you can see, as you will see, is pretty similar to the example that I gave you initially. The cool thing about MobX is that you can put your observables anywhere. It doesn't matter. You can, in the first example, I put them on window, even though you will probably never do it. I put it on window exactly to emphasize that it doesn't matter where you put your observables. In this case, I just choose to put it on the React component instance. I mean, I put it directly on this object. And you don't have to do it like this. Maybe you want to create your MobX state or whatever property. Maybe you want to access it from somewhere else. In theory, the counter property, you can access it from outside the component. So MobX doesn't restrict you from doing it. It's not that MobX offers an alternative for set state. It's just that you can use it in such a fashion that it mimics the behavior, and it's up to you to define your constraints over, look, let's not access that property from outside of the component. So this is up to you. So it happens to simply work and mimic the behavior of set state and to fix all of the issues that I described previously. I mean, this call is synchronous. After handle increment, if I check this counter, it's going to be 1 without any callbacks or whatever. If I, let's say, assign a value to this counter that was already present in the object, the component won't re-render because the value hasn't actually been changed. And the best, sorry. Okay, and it captures component state, and if you want to put a timeout ID or something, you have the freedom to put it right next to your properties on this. Again, this is up to you of how you structure your code. So yeah, this is a summary of what I've just said here. So any questions regarding this pattern? I'm also going to illustrate a small demo that I did. But I first will go through all of the patterns and then take them one by one and present to you the code and how does it work. Third pattern is more exciting than this. Okay. The second one is that in MobX you have the concept of computed properties, which are like regular JavaScript properties. They have a getter and a setter, but they work in a similar fashion to how the render function reacts to changes in its dependencies. So let me illustrate you an example. So sum and average are computed properties. They are going to automatically be converted to computed properties by extend observable. Extend observable is not the only way in which you can define observables, but it's the one that I use the most. So I use it in this example also. So as you can see, in the properties themselves, I'm doing some, let's call them complex calculations, even though they are not. But in your large-scale real-life application, you might have some sort on an array of 1,000 elements, and then you need to map all of the elements to a new object, something like this. So you want to somehow cache the result of that operation and only recalculate that property when its dependencies have been changed. So in this example, as you can see, in the render function, I'm only using the average computed property. I'm not using sum or numbers directly. But in the event handler for the button, I'm updating one of the elements in the numbers array, which is a dependency to the sum computed property, which in turn is a dependency to the average computed property. So what MobX does is that it deeply tracks your dependency. So it constructs a tree of all of your dependencies down to the last one. So when I actually change that property, the render function is going to be re-invoked because a dependency of the average function has been changed.
Sorry?
Yes.
Does it handle cyclic dependencies?
It's going to trigger an error if you have. Yes, I actually got into one today for the first time. But I never, in my project, I never encountered that situation even by mistake. I mean, I haven't run into that kind of situation. But yes, if you have a cyclic dependency, it's going to trigger an error. Okay, and also, if you can see, I put those properties directly on the React instance again. So you still have the freedom to use computed properties as well, wherever you want them, including in the React component instance. So I hope you can see how this can become a very powerful tool to move some of your logic from functions that make some sort of a small transformation over your data and put them in those kind of properties. I mean, you can still store them in functions. You don't have to write the code directly into the getter body itself. You can store it in a separate function, but if you call it within the getter, you will go through MobX's pipeline, and it will track all of its dependencies, and that property will get recalculated each time one of their dependency changes. Okay. And the last one, and the one which will probably challenge you the most. While writing API connectivity layers. So as a front-end developer, we probably have an API somewhere. We have some methods for connecting to it, which are usually something like fetch, new, create, whatever for each type of entity. And you usually communicate with that through callbacks. Your methods in the API connectivity layer accept a callback, or you can return a promise, or you can return RxJS observable or whatever. And the result of that call is going to be included into the callback response. And then you subscribe to that event and take that data and do something with it, usually outside of the API connector layer. And also, when you store the asynchronous state, something like is loading, the progress if you're doing a file upload or something, usually from what I see in other developers, they don't tend to store that state on the target entity itself. Maybe they have a global is loading property somewhere in their stores or whatever, and when something happens to a particular entity, they simply make that to be true while the request is running. They block their part of the user interface that uses that component, but is not stored on the entity itself. So I find that using that approach has a few limitations. One of them is that you might have separate state if I have some methods for fetching and updating an entity. By the way it's implemented with an external asynchronous state, if I have an isLoading property that is going to be somehow internal to the API method or stored somewhere else, those are independent variables defining those states, but in practice they are never going to be run at the same time. I cannot think of a scenario in which we want to fetch and update the same entity at the same time. So in theory you can encode the asynchronous state of an entity using one property that might be, I don't know, a list of constant, it might be an enumeration or something like this, in which you can say what is happening with that entity at that particular moment. Also, if you think of a file upload, which is what the demo is going to be based, a file upload has intermediary progress. I mean, right off the bat, you cannot return a promise, because the promise will simply be either resolved or rejected when the request gets completed. But if you want to also have a way of subscribing to progress changes, you need to pass a second callback, or you need to somehow keep that state somewhere and to get it out of the XML HTTP request object. So again, if you are using Redux, for example, and you don't store that on the entity itself, maybe you can store it, or you put it on your store. If you have multiple uploads running at the same time, maybe you need to make an array of progress indicators for that particular entity. So it becomes, again, you have something related to the entity that is not in the entity itself. And it becomes difficult to access that and correlate with your entity. If you have a component that renders the progress of your upload, you need to first access the entity, see what's with it, but also to access somehow the progress of the upload. So, while trying to tackle all of these issues, I try to forget everything that I know about how I should write an API connectivity layer, and I just went at the solution that made the most sense to me and was the easiest to implement. And that is to put everything regarding the synchronous state on the entity itself. Meaning, if that entity can be fetched or updated or whatever, the synchronous state is going to be stored on the entity itself. If it's something that, like a photo or a file or whatever, that can be uploaded, again, the upload progress is going to be stored on the entity itself. Most of the time you won't use that in your UI components, but you will use them when you make a call and you need to display a loading indicator or something, and you have fine-grained control over that, because you can display a progress indicator for each particular entity in part. So also, if you want to display some sort of aggregated loading bar for all of the entities or whatever, you can make use of MobX's computed properties. I mean, I have, let's say, 5 photos that are uploading all at the same time, each one with its own individual state, but I can make on my store some computed properties which tell me if at least one of the files is processing, is currently communicating with the backend. I can make some aggregated calculations over how much has been uploaded or what's the total upload size or whatever. So, okay. How do you change that entity? Right now I'm experimenting. I cannot say that is the best option or the worst or whatever, but it has worked for me to always ensure that for each entity that exists on the backend. I have at most one entity on the front end, so I can correlate them one to one. Even though I don't have the entity yet on my front end code, but I know it exists on the backend because I have an ID for it, I can simply create an empty instance of that entity class, and I can pass it directly to the API connector, which makes the call, and when the response comes, it will simply write all of the data into the entity itself and update its asynchronous state. And the same can be applied for if you are making a file upload, for example. You can create the entity from scratch. You can have an upload progress property, an observable one on the entity itself, and you can give that to the API connector, and whenever a progress event occurs, it will write the progress into the entity itself. Okay, let me quickly illustrate the demo for it. I need both hands free. Yes. Okay, this is a beautiful demo. It's just a collection of photos that are fetched from the backend, and you can do multiple uploads with them. Just quickly going to demonstrate how it works. Hope it doesn't crashes. But in fact, let me first simulate the slow connection to see what actually happens. And the whole purpose of this mini demo is just to illustrate how simple it is to use MobX to achieve this result. So as you can see, each photo has its own individual upload progress, but also you have some sort of aggregated information about that upload at the bottom of the page. And also, apart from it, when fetching the photos from the backend for the first time, I simulated a scenario in which the data is not complete. I mean, I only get the name, I get the name of the photo, the URL, and its ID. But if I hover over it, I should see more information. And it doesn't work as expected, but what happens when, look, if you can see, when I hover over it, it makes a request to the backend, fetches the additional information, and writes it down back into the entity. So now I'm going to show you how simple it is to achieve that using MobX. Nu știu cum să orice și Okay. So this is the photo entity class. As I described earlier, apart from the regular properties of that class, you also have something related to the synchronous state of it. This property can be set. You can use a set of constants or whatever, doesn't matter. These were invented by me for this particular scenario. Let's say it can be, the sync state can be either new or fetching or synced or partially synced. However do you think it represents best your scenario. And also upload progress size, whenever the file is going to be uploaded, represents the amount of bytes that have been uploaded to the backend. It's just returned by XML HTTP request. And also I have some computed properties here, which are not very fancy. But upload progress is going to be the percentage of the upload that has been completed. It's going to be a number from 0 to 1. Let me go to the API connector now and show you what happens when the photo gets updated. as you can see, the argument for it is a photo entity. Sorry for not writing comments to it. It's on GitHub, and I promise I will comment that out for everyone who is interested. I'm using plain XML HTTP request, and this is on modern browsers is considered to be XML HTTP request 2, which supports reporting progress of the uploads. So this is the callback for XHR that gets triggered each time progress has been reported. And as you can see, nothing very fancy happens here. I just write down that property onto the entity itself. And what happens here is that exactly at this moment in the code, my user interface is going to be already updated. I mean, because on the photo entity, upload progress size is unobservable, and I'm also using it in my React component somewhere around here, and the React component is an observer. Each time I change that property, doesn't matter from where, the user interface is going to be updated. And also, as you could see when I made an upload, we also had that aggregated summary bar at the bottom. And again, what happens with this is that simply I use computed properties on the stats component to simply, first let me show you how they are calculated. So this is my store in which I have, again, as you can see, I'm using the same constructs for both the store and the React component. So very minimal boilerplate footprint, however you want to call it. You can use it both in your stores and the React component. It uses exactly the same concept. So all of these are computed properties. First, I have a list of photos that are currently uploading. I'm filtering them by the sync state, and based on those, I make some calculations on how much has been uploaded, what is the total size, whatever. Those are computed properties on the store, and those computed properties from the store are in turn used on the stats component that you see on the bottom of the demo. So basically, I have some more concepts. Nu vreau să te dai mai timp. 11 minute mai am?
Tot cu întrebări.
Ok, atunci ai că termin repede. Poate degetul e așa. Okay. So, in fact, questions regarding this particular demo and this latest pattern? Întreabă ceva. Sorry?
Isn't this just like anchors to related binding, two-way data binding?
You might consider it to be that, but in Angular you have to I don't like the way the code looks in Angular. I only used version 1 and I had a lot of trouble figuring out why those watchers are getting triggered 10 times for a single update. So you can compare, I mean the functionality is the same, but the way it behaves, I would consider them totally different. I mean, Angular is totally unexpected in the way it behaves. Again, I'm talking only about version 1. Version 2, I don't even want to. Okay. Sorry?
4.
No, I stopped at 1. It was enough for me. Moved to React and never looked back. So, yes, it's sort of like, I never thought of it in these terms, as two-way data binding. I mean, as you can see in the lessons that I learned from using MobX, I don't even think anymore of the technology when using it. I mean, it becomes like, I don't know, ingrained into, you feel like it's ingrained in JavaScript itself. I mean, you just know you have some properties, have some state, you update it and your user interface gets updated. Same happens with React. I mean, I have the same feeling when dealing with React. I never encounter issues in which I need to bash React itself. Well, I'm exaggerating, I have a few, but I usually don't encounter issues that how do I do this with React. No, I figured how to work with it, how to use it to attain my goals. Same with MobX. I learned how to use it. It's not very complicated, and I just do stuff with it. Right now I'm only concentrating on how to implement new functionality, how to maintain the current one. So I never think of those libraries. I mean, they don't pose any problem for me right now. I just use it like they're there. So don't compare it to Angular, please. So what I just told you is a few of tooling.
Ai Redux, ai chestia aia, vezi clar, ok, s-a întâmplat despre acesta, deci la time travel, vezi frumos cum s-a întâmplat, acum ați fiind 3 programatori proiect, toată lumea schimbă obiectele alea, itează din toate părțile cu 70 de funcții sincrone, e ia după cum.
Okay, so Adi is my Redux counterpart here. He's the one with, but his question is about the tooling in MobX, because in Redux, even though I haven't used them, but I saw it on his desktop and he was very proud of it. You have the option of seeing exactly what has triggered the particular, when you enter a reducer, you see exactly why and how the state gets mutated from one, how it passes from one state into another. And you can see that very elegantly into, how is it called? Redux?
No, DevTools sau ceva.
DevTools, whatever. Yes, for MobX, the tooling, I would consider it right now to be a little bit limited, but you can see, for example, what observables, you can inspect it directly into your React data structure. You have a tool called React MobX DevTools, I think it's called, and you can simply click on an element on your page directly, and it will display what kind of observables is that component using. Also, you have some utilities in the library itself. You can put some, I don't know how is it called, why it rendered or something like this. It has a pretty intuitive name, which will log effectively why that render in your component has happened. I never used it, but again, I never used it because I was never in a situation in which I needed those kind of tools. I understand why you would think about that if you come from a Redux background, but when using MobX, it's a different kind of perspective. You stop thinking of your application as a top-down, unidirectional data flow in which you need to be the master of the universe and know for absolutely each tiny click why something changes in a totally other part of the application. And usually that was my biggest problem with Redux, the boilerplate. I mean, I don't like it, to be honest with you. So I understand why you might be concerned about the tools with it, but in MobX, my personal experience is that I never used, I never needed that kind of tools. So.
I have a last question.
Yes.
What about multi-level objects, observables with multi-level objects?
Sure, this is something that I wanted to suggest in the first of the last slides. Again, I haven't gotten into the depths of how it works, MobX, how MobX works, but you have, you can create nested observables. You have the control of making either shallow observables, so only the top level properties are observables, but the rest are just plain objects or whatever you want them to look like. For example, in this case here, as you can see for the array, I mentioned that it's going to be automatically converted to an observable array. It's just a structure. This is how it's called, observable array in MobX. It has all of the properties of a native array, plus some additional ones, like delete, peek, something like this. And it also has observable map. In MobX you have 4 data structures. You have observables themselves, you have observable arrays, observable maps, which are very similar to maps in other languages, and you have boxed observables in which you can pass it a primitive value, and it wraps it in some sort of observable thing that you can monitor. But again, that is something that I didn't use. I didn't feel the need to use at any moment. So you are only going to use those 3 components, which are basically what you also get in JavaScript. You have primitives, you have arrays, you have objects, like literals. So, but each function, for example, extend observable, has a counterpart, extend shallow observable. Each data structure has a counterpart, shallow observable array. So you have a very fine-grained control over what do you want to make observable and what not. I mean, extend observable is going to deeply convert all of your data structures to observables. So if numbers was an array of objects which each had another array as one of their properties, and I call extend observable like I did, and I modify something very deep inside the observable structure, is going to pass through the same pipeline of MobX. And again, it depends on how do you use it. I mean, if I, for example, in this case, if I were to use just the numbers array inside of the render function, so I'm not using a property of it, I'm writing this dot numbers, and I change a value, or I push a value inside of the array, nothing will happen because I didn't change what this numbers is actually. I didn't change the instance of the array. I only changed a property of it. But if you access one element of the numbers array, if you index it or something like this, yes, it's going to be re-rendered if you update that particular element. But only if you use it. I mean, if I use the second element in my array in my render function, and I modify the third, the re-render won't happen because I didn't change the second element. So it has a very granular. You have a very granular control over when re-renders happen. It only re-renders when things actually change, and never when they don't. Okay, so yes, for those who are curious about MobX, what you can learn more about it is to look at the additional data structures. that I mentioned to you about. Learn how you can declare observables using various, for example, you can use decorators to declare observables as well. Instead of using extend observable, I can put the numbers on the class itself directly. I can put an observable decorator behind it, and it would have the same effect. But then you would have 3 observable decorators, and if you have 10 properties, you'll have 10 observable decorators, which doesn't look very nice. This is how you will find them on their website. But personally, I find that this is more, it's like an object assign. This is like an object assign on steroids. This is how I would call it. So also you can understand how MobX reacts to changes, and you have a lot of functions for reacting to changes. What I presented here is just using React, the library, but again, it's not just for React. At its core, it's just a way of, it offers an interface for subscribing to changes to your data model. So you have a lot of methods for monitoring it. You can react just once to a set of changes. Sorry. I'm going to finish. So, sorry.
You gotta finish.
Sorry?
You gotta finish.
De ce zici mă asta? Ești obraznic? Uite. Thank you.
That's about it for tonight. Thank you so much for joining us. See you in 2 weeks. Am I right? In 2 weeks with another great speakers, another good tech presentations. Thank you once again for joining us. Please stay over the night for a beer, some not really, but there is a karaoke party here at 3, so maybe you are interested. Thank you.